Welcome everybody to Pure Virtual C++ 2023. This is our fourth year running. It's a free annual virtual C++ conference for the whole C++ community. And today we have 5 talks for you. We have myself, who's going to start off with C++ compiler errors for humans. Then we're going to have Jim Radigan on address sanitizer with the continue on error mode. Tony Van Eerd is our guest speaker for today, who will be talking about value-oriented programming in C++. Sina Makinja and David Lee will talk about productive cross-platform and game development in Visual Studio. And then Gabriel Dos Reis is going to finish us off with build time reflection with C++ in year 2023. I will have chat open during my talk, so I can see all of your comments. Seeing, hey, everyone. Feel free to say hi, tell us where you're coming from. And I'm going to kick us off with my session on compiler errors. So for those of you who don't know me, I'm Cy Brand. I am the C++ team at Microsoft's developer advocate. And today I'm going to talk to you about how we can make C++ compiler errors for humans rather than for robots or something else. So to start off with, I wanted to give you a quote from from someone who runs the diagnostics team on Rust. It says, compilers are an error reporting tool with a code generation side gig. Now, you may agree with this, you may not, but the important thing is that error reporting matters. The compilers have to tell us how we can solve our issues and to make us understand what we've done wrong. Otherwise, we can't get anything done. So with that in mind, this is what I'm going to be talking about today. What makes a diagnostic good? How can we judge diagnostics? What criteria can we use? How can we improve them? What do other languages do? People in chat are already talking about Rust and how we can learn from Rust, and I'll talk a little bit about that and see what other people in the industry are doing and how we can learn from them. I'll talk about the developments our team has been making in MSVC on compiler errors. I'm going to talk about some more work we're planning in the future. We're doing some prototyping work at the moment. And then if we have time, we will have some Q&A. Feel free to drop questions in the YouTube comments. Just while I'm talking, I will keep an eye on them. If you do want to get involved in the conversation, please go over to aka.ms/purevirtualcpp/watch or go to the Visual Studio YouTube channel and you can join in the chat that way. Okay, so what makes a diagnostic good? I asked myself this question, spent a bunch of time thinking about it, and then I thought, well, maybe I could write a paper which talks about what makes a diagnostic good? What are people in academia studying in diagnostics? What are people across the industry doing in production compilers? So I did exactly that. I wrote this paper, Concepts, Error Messages for Humans. This was focused primarily on concepts, but it is applicable more generally to compiler errors. And I sent this to WG21, which is the ISO C++ committee. And you can go read it there if you like. A lot of what I'm talking about today comes from this paper. So you can go to wg21.link/p2429 to read all of the details. It's a fairly lengthy paper. But my idea was I wanted to prompt discussion about what's desirable and feasible for improving the diagnostics output by C++ tooling. So I spent days, weeks reading as much academic literature as I could find on compiler errors, looking at production compilers from across the industry and seeing what I could glean. But first, on the importance of compiler diagnostics. I had that quote at the start that they're error reporting tools with the code generation side gig. I did find a paper which did empirical analysis into the importance of diagnostics using actual experiments with students. And they noted that programmers do read error messages as much as you might see people on Stack Overflow putting forth a question where the error message tells them exactly what's gone wrong. Programmers do read their error messages. Furthermore, the difficulty of reading these messages is comparable to the difficulty of reading source code. Now, reading C++ source code is a bit more difficult than some other languages, and our error messages are kind of similar. It's generally more difficult to read a C++ compiler error than something coming from many other languages. Difficulty reading error messages significantly predicts task performance, i.e., if you're struggling with your error messages, you're going to struggle to get anything done. And then participants allocated a substantial portion of their total task to reading error messages. People spend a bunch of time reading these things and trying to work out what they've done wrong. So the easier we can make that, the better. So I'll talk about a few of the criteria on which diagnostics can be judged. One is cognitive load. How much does this diagnostic weigh on the mind? And in C++, we're great at this. We get compiler errors like this. If I expand this out, you can see it's basically just a massive template instantiation failure. This is the kind of thing where we run compile, we see this in our terminal output, and we just want to go to sleep or go learn a different language. It's not great. But what are some of the things which we can do to lower cognitive load? I found one paper which specified that we can lower cognitive load by placing the relevant information near the offending code. This could mean printing out some source code, like interspersed with our error. It could mean putting our error directly in the editor with some squiggles or something like that. We can also lower cognitive load by reducing redundancy, trying not to repeat ourselves. We can also lower cognitive load by reducing redundancy, trying not to repeat ourselves. And then finally, we can use multiple modalities to provide feedback, i.e. we can use the editor window, we can use an output window, we can have an error list with different ways of telling the user what has gone wrong, because different people will want to get this information in different ways. The more ways which we can reasonably communicate in an effective manner, the better. Context. We need to know as much about the errors as we can. I read this paper from 1974. People have been studying this stuff for a long time. What the compiler should tell the user. And it says, one of the hardest things to remember in designing error diagnostics is you don't know what the error was. If the compiler knew what was wrong, it would just tell us. Some pieces of information have been found to be inconsistent, but it cannot be said with certainty where the error lies. Maybe in some situations, the compiler can say, hey, maybe this is what you meant, but in general, it's not possible. It also has this piece of advice. The safest strategy is to describe the symptom as clearly as possible before attempting to make any suggestions about the nature of the error. So making a suggestion is all well and good. Hey, maybe you meant a semicolon here. Hey, maybe you meant this function. But in general, it's best to give the user as much information as they need to diagnose the error before then making any suggestions. So say we're using C++ concepts, what would users need to know? It's like an example of how we're thinking about what context to give our users. Well, I think that one, they need to know which constraints failed and why. If you decorate some function with some function template with a constraint, maybe you have multiple constraints. So you need to know which one failed and why it failed, what was found to be the issue. Furthermore, if you have an overload set, you have multiple candidates considered, which ones were considered and why was each candidate discarded. Because if we just look at one of them, well, maybe we didn't even mean to call that overload. We need to look at the entire set and understand why they all failed. Readability. Readability, this really annoyed me. I looked at so many papers about compiler errors, and all of them were like, you have to make your error messages readable. And none of them said what that means. None of them said, like, here's how to increase the readability of your error messages, or here's the criteria we're judging readability by. It's very frustrating, but I did find a paper which I think found some good ways to judge this. One said that experts, non-experts, and students assess the readability of messages differently. I.e., if I have some domain knowledge, some specialized domain knowledge, maybe a given error is more readable to me because I can quickly understand, oh, well, there's some complex concepts here, but I already have an understanding of this. Yes, this video is live. I'm seeing your comments. So if I have that domain knowledge, it's more readable to me. However, if I'm a student, if I'm coming at this without that necessary knowledge, then I'm having to parse a lot of complex concepts in order to understand this message. Therefore, it's less readable. Error messages from different languages are perceived to have different levels of readability, which we're very familiar with as C++ programmers. Shorter messages tend to be more readable. If I don't have to parse a huge amount of text on the screen, then it's going to be more clear and understandable to me. Interestingly for me, this one, messages phrased positively tend to be more readable. So trying to avoid negative phrasings actually makes it easier for us to parse our errors. And then messages with more jargon and acronyms tend to be less readable. If I'm writing a C++ program and I see an error with svine in it or something, maybe I'm going to know what that means, but someone else will not. So you need to think about who your audience is, who you're writing your errors for. Going back to that positive phrasing, positive tone, I found this delightfully named paper, How a Computer Should Talk to People, from 1982. It says, we learn about and use a computer more effectively when we feel secure and experience success with it. Think about times where you're just having a great day, getting a ton of code out there when it's all working. You feel great about it. If you're just banging your head against error messages all day, not so great. What helps us feel at ease with a computer program or a system? Friendliness. Or put it in a slightly different way from the folks on the Elm team, compilers should be assistants, not adversaries. I really like this quote. This is something to live by. Our compilers should help people. They shouldn't be something which you're constantly fighting against to convince that your code is valid. They should be helping you express what you want. Okay, and then there's a bunch of other ones. Providing examples. If the compiler says, hey, you've got this error, here's something which presents the same error, but is maybe a little bit more cut down, because often there's a lot of context, a lot of code that we're having to deal with. It's not just the pure error itself. Having a small distilled example can really help. Providing solutions and hints, saying, hey, maybe you meant this, but maybe you had a typo in your function call. Maybe you missed a semicolon, this kind of thing. Dynamic interaction, being able to say, I'd like more information about this error, please, and have the compiler delve deeper into the issue. Logical argumentation, this means walking you through what the compiler thought when it was diagnosing your issue, saying, hey, you can't call this function or this overload set because all of these failed. And here's why each of them failed, walking you through the steps that you need to know to say, okay, this is why this error happened. If you don't have that context, that logical argumentation, it can become very difficult. The topic of this is on compiler errors for humans. Diagnosis time. When are we diagnosing errors? Are we doing it while the user is typing? Or are we doing it when they run a build? Are we doing it in CI? There's a bunch of different times where we get back these errors, and thinking about which errors we're producing when can help aid in lowering cognitive load. All right, let's talk about other languages. Talk about Elm. So Elm is a functional language for the web. It's very cool. I've played around with it a bit. It's really, really fun. And this function, well, this program just says that our main function is print 4 to the screen using this text function. However, there's an issue here. Text takes a string, not an integer. We need to convert the integer to a string. So helpfully, Elm diagnoses this for us. Hey, Kenya. It says the first argument to text is not what I expect. Note that first person pronoun in there, not what I expect. The compiler kind of talking about itself as a being. Some people like that, some people don't. I think it's kind of fun. It helps to it aids that friendliness aspect, that positive tone. Then it gives us our context. It gives us our code right there, helping lower cognitive load. We don't have to jump around. It says this argument is a number of type number, but text needs the first argument to be a string. So this is logical argumentation, telling us exactly what has gone wrong and why. And then it gives us a hint. As try using string.fromInt to convert it to a string. Very helpful. This is a good error. I think very readable, very understandable. Another one from Elm, which I found, was this tweet: "Thanks Elmlang for the most useful error message I've ever seen." It says, it's a little bit more complex. This type alias is recursive, forming an infinite type. This is like if you are in C++ and you have a struct which you try to contain in itself. Not going to work. So it has a type alias, and it says, when I expand a recursive type alias, it just keeps getting bigger and bigger. So de-aliasing results in an infinitely large type. Try this instead. And in Elm, you can use create a new type instead of using a type alias, and this solves the problem. Then it says, this is kind of a subtle distinction. I recommend the naive fix, but you can often do something a bit nicer. So I'd recommend reading more at this URL. So this is giving you the opportunity to go read more about exactly this issue. It's giving you a suggestion. It's giving you more details about specifically the error which you're looking at. I really like this. Then I want to look at ReasonML. ReasonML is like a resyntaxing of OCaml, basically. This is what their errors used to look like. They did a bunch of refactoring. And it's kind of fine. It says, this expression has some type, but we expected something of a different type. Because there's an incompatibility. But it's kind of just a blob of text. It's not very easy for me to read. So what they did is they pretty much kept the same content of the errors. They just changed how they're presenting it to the user. So this is their old version, and then the new version looks like this. We found a bug for you. And again, lowering cognitive load by placing that code right next to the error so you can see exactly what it's talking about. Then they thought about how to format this nicely so it's readable. They thought about making sure that everything is well-defined visually, that they're using short blocks, that there's some coloring there to aid in comprehension. It's not like fundamentally different from the error which was presented before, but I think it's many times better, many times more readable, understandable, lower cognitive load. I want to spend a bit of time on this Rust code. So you don't have to understand Rust. I will explain this. Basically, what it's doing is taking an array of 3 integers, 0, 1, 2. It's taking an iterator into it, which is like a range in C++. And then it's trying to intersperse the value 100 between all of these. Then what it's doing is trying to partition this result in place, so not allocating more memory between odd and even. However, there's a couple of issues with this code. One is the partition in place requires bidirectional or double-ended iterator, and intersperse is not one. Furthermore, partition in place, because it's doing it in place, it requires the range to the iterator to be mutable, and intersperse is not mutable. So there's 2 issues there. And ideally, we want to get diagnoses of both. And that's exactly what Rust does. So I've split this up into a few slides. Focusing on that first one. Here we go. The trait-bound intersperse double-ended iterator is not satisfied. Okay. And it shows us exactly where in the code. It even has those little chevrons underneath to point out exactly the function call where this happened, and says the trait double-ended iterator is not implemented for intersperse. And that this is a problem because it's required by a bound-in partition in place. So this is pretty readable. It's giving us a lot of context and logical argumentation. Then it diagnoses our next issue. It says, furthermore, we expected this intersperse thing to be an iterator that yields a mutable reference, but it yields a regular reference to an integer. And it says the types differ in mutability at this position. And again, that we expected a mutable reference, but found a regular one. Then, and this is the bit which I find really cool, it gives us more information about our call chain. It says that the method call chain might not have had the expected associated types. So just in case you had expected something to be mutable, like halfway through, it actually walks you through the call chain, not line by line, but expression by expression, telling you what these types are, which I find really, really cool. Like, it tells us that the array is of type an array of 3 integers, that iterator item is a regular reference here, that it remains a regular reference through the call to intersperse, and then through the call to into iter. So this gives us really, really nice logical argumentation. And then finally, it tells us, okay, we're aborting due to our previous 2 errors. Some errors have more detailed explanations, and you can go and find out more about these. So this is giving us that dynamic interaction. Okay, I want to talk about compiler improvements which we have been making in MSVC. Let's look at some code. So I've got some C++ code. I've got a dog and a cat. And of course, I want to be able to pet my dog and my cat. But say I also want to be able to call pet on some other types which are defined elsewhere. Maybe I want to be able to call pet as a non-member function as long as a type has a .pet member function. So I could express this using C++20 concepts like so. We say we have a concept petable. Don't really have to be able to read concepts. This basically says something is petable, some type T is petable so long as, given an object T of this type, you can call t.pet. And then we have a function template down here called pet, which we say we accept anything which is petable, which satisfies this petable constraint. Okay. What happens if we call pet 0? 0 is neither a dog nor a cat, nor does it have a .pet member function. So this is an error. This is what we used to print out. Said pet, none of the 2 overloads could convert the argument types. It could be the cat one, it could be the dog one. It can't be the dog one because you can't convert into dog because there's no relevant constructor. It doesn't tell you what was wrong with the cat one. It doesn't even mention the function template. If we get rid of the cat and dog overloads and just keep that function template, it says that we couldn't call pet. It could be that template version, but the associated constraints are not satisfied. It doesn't tell us what constraint wasn't satisfied. It doesn't tell us why. That's all the information we get. So this is kind of where we were with the old version. With overload resolution, like sometimes it would only list the last candidate. Sometimes it would list all the candidates but not explain why they all failed. Sometimes it would often ignore template candidates like you saw just there. With constraints, we would just say, hey, constraint not satisfied. You wouldn't get any details about why. And additionally, sometimes the line information was correct or missing. So for this, we've been focusing on context and logical argumentation and trying to fix all of these issues. So now if you do this, you get an error like this, which says, couldn't call pet. It could be the cat version, but was not valid. Or it could be the dog version, not valid because of these reasons. And then for the template version, it says, well, the associated constraints aren't satisfied because petable int evaluated to false, because the left.pet must be a class or structure union, but the type is int. So this is giving you all the necessary context you need to solve your issue. One thing to note here is that there's a hierarchy here. There's a structure which isn't necessarily represented in this textual format. It looks something like this, where we have our top level entry is our no overloaded function could convert the argument types. And then we've got our different overloads, the cat, the dog, the template version, and we've got all of the associated reasons those couldn't be called. So there's a structure here which isn't represented just in the text. So what we've gone and done is supported outputting Sarif information. Sarif is a JSON-based format for code analysis errors and compiler errors, and it looks something like this. Don't want to spend too much time on this, but basically we have a message that says, well, no overloaded function could convert the argument types. And then we have a related locations field And that is where we can represent our hierarchical information. So this can now be produced by our compiler. And we're planning to use this for some future work. So the future work, what we would kind of like to see, this is just a mock-up for now, it's something like this, where in your error list, we don't have all that hierarchical information taking up space. We put the top level entry in the error list, and then there's a details field where you can click. So if you see an error and you're like, okay, well, I want to dig deeper into this error, you can click this problem details button, and this will open up all of that hierarchical information so that you can navigate it and click around, see your editor, go to the correct place, all the kinds of stuff which you would expect. And this gives you a way to navigate through your hierarchical errors. Very quickly, I'm going to show you a demo of a prototype we have of this. So this is basically what I had before. I've got my dog and my cat types and my functions. I've expanded this a little bit. Now, petable concept is, well, it's either has a member pet function or it tells you that there's a default implementation to use. And then these are defined like has member pet says what you can call .pet on it, and default petable says that T has some is petable static bool member. So then what happens if we try and pet a donkey? Well, if I run a build here, then there we go. We get top level entry here. And if I click on this, then it opens up my location here and my related locations. So now I can step through this and I can say, hey, well, it could be the cat version, but I can't convert argument 1 from donkey to cat. Why? Well, because there's no user-defined conversion operator available. Or it could be the template version, but the associated constraints are not satisfied. Okay, why? Well, because petable donkey evaluated to false. Okay, why? Because this is a disjunction, both has member, pet donkey, and default petable evaluated to false. Okay, why? Because pet is not a member of donkey. And then we can click on this to see the definition of donkey. So this gives you a really nice way to be able to navigate through very complex errors in a way which we simply haven't had before. So that is all I have to show for today. If you have any feedback about this or things you would like to see in these kinds of features, please let me know. You can drop me an email at cybrand@microsoft.com. And this has been C++ compiler errors for humans. Thank you very much. Now we've got, where are we for time? Okay, we have 2 minutes scheduled, and I left a 5-minute leeway, so we've got some time for Q&A. If anyone has any questions, feel free to drop them in the chat, and then we will move on to the next session. This thing, by the way, has been a lifesaver for me. Remind me when to drink water, because otherwise I just forget. And you can, of course, go and look at my paper, which is at p2429, wd21.link/p2429, if you'd like more details. I summarize a lot of the literature which I went through and have a lot of links to academic papers if you'd like to have a look. How are you feeling, Si? I'm feeling good. I'm looking forward to the rest of the sessions. What was the demo about? The demo was showing prototype work, which we've been doing in Visual Studio to surface these hierarchical errors and give you a better way of navigating them, easier way to access our context and logical argumentation, and comprehend your messages with less cognitive load. just wait for a few more questions, and then we'll move on to Jim's talk. Jim is going to be talking about address sanitizer and the new continue on error support, which is something I'm very excited about. What sort of timescale are you looking at for preview? So we still have some, I can't share exact timescales, but we still do have time to integrate feedback from all you folks. So if you, for example, looked at my the mock-up here and immediately thought this is terrible for my workflow or something like that, or if you looked at the prototype and saw ways which you thought would work better for the kinds of errors which you're dealing with, we have time to integrate that feedback. So please do let us know if you have any of that. Russ C is saying, thank you for driving the effort to improve error messages. Please don't stop. Yeah, it's not just me. It's also folks at Clang and GCC have been doing a lot of great work in this area as well, and other folks on our team as well. So this is, I think, an industry-wide effort to try and improve the state of compiler errors in C++. In which version of Visual Studio can we test this? So you can't test it right now. Keep your eye out on the Visual Studio C++ blog for when we announce the availability, or also in the release notes for Visual Studio. Well, I think that we are good for questions, so we can move on to the next talk.